In this video we're going to look at dividing fractions. Here's page 1, and then we'll do this page 2 here with these two examples. So it's just an introduction to dividing fractions. So I'm just going to start, if you could please write these guys out. 10 divided by 5, 10 divided by 2, all the way to 10 divided by 1/10. And we'll try to understand the pattern of dividing. Okay? So, press pause if you like and write those out. Please write those out. Okay. Okay, so when you're ready. Okay, so 10 divided by 5, we all know is got to be 2, right? 10 divided by 5. But one way of looking at this is saying how many 5s are contained in 10. So it's kind of like starting, instead of you could think, okay, 10 split up into 5 equal parts gives you 2. You could also think how many 5s are contained in 10. In other words, excuse me, if I think about this, okay, 5 plus 5, 2 5s make 10. Okay, 2 5s are in 10. And if you look at 10 divided by 2, you can think how many 2s are contained in 10. How many 2s do I need to add together in order to get 10? Right? 1, 2, 3, 4, 5. 5 2s, right? Now, if you look at 10 divided by 1, how many 1s are contained in 10? How many 1s do you need to add together to get to 10? Right? Well, surely we know the answer to that one, right? 1, 3, 4, 5, 1, 3, 4, another one, right? Obviously it's got to be 10. So 10 divided by 1 is 10. Now, that might help us understand this. 10 divided by 1/2. How many halves do I need to add together to get to 10? See if you can figure that one out. You don't have to write it out. I'm just trying to visualize, show you the visual on this. It's quite a lot, isn't it? You know that 2 halves makes 1, don't you? Right, so here's one. Here's another one. There's another one. So how many 1s do we need? We need 10 1s. And there's 2 halves in every 1, right? So what do you think the answer is? 10 divided by 1/2. Think it's 20? 20 halves? Yep. Good job. If you had $10 and you wanted to change that $10 into quarters, 10 divided by a quarter would say how many quarters are contained in $10? How many quarters would you get if you changed $10 into quarters, right? 25-cent pieces, or $0.25. How many quarters is that? Can you get that? In other words, how many quarters would add up to give $10? Well, there's 4 quarters in $1, right? 4 quarters in $1. So there's another 4 quarters gives you $2. So there's 8 quarters in $2, right? And so on. So in $10 isn't there 40 quarters in $10, right? So in any case, how about dimes? 10 divided by 1/10. How many tenths do I need to add up to get to $10? So you're thinking adding tenths. 1/10 plus 1/10 plus 1/10 plus... How many dimes add up to give $1? 10 dimes in $1, right? 20 dimes in $2. 30 dimes in $3. So eventually, wouldn't there be 100 dimes in $10, right? Anyway, let's just say there's 2 reasons for that. One is to understand what dividing is, and the other thing is to understand the dividing by fractions rule. If I'm dividing by fractions, let's just take this 10 divided by a quarter out of there, and look at that. 10 divided by 1/4. The rule is you multiply by the reciprocal of the fraction on the right. So the reciprocal of the fraction on the right is 4 over 1. You flip the fraction on the right upside down, and then you multiply it. And that's the rule for dividing by fractions. So now we have 10 multiplied by 4 over 1, which is the same thing as 10 multiplied by 4, isn't it? Which of course is 40. And of course that is true, that 10 divided by a quarter is 40. We worked that one out, didn't we? And the same can be true for all of these, you know. Your 10 divided, or sorry, 10 divided by 1/2, instead of dividing by a half, you can multiply by 2 over 1. So 10 times 2 over 1 would be 10 times 2, 20, right? And so on. Alrighty. So, what about this guy? 2 divided by a quarter. See if you can just write down the answer first. How many quarters are contained in $2? I mean, it's important to understand where these rules come from. I mean, it's no point just remembering to flip the fraction and multiply because the teacher said so. I mean, where's the education in that? You know, so I think anyway, it's important to understand why. So anyway, that's what we're doing here. We're going 2 divided by a quarter means how many quarters are contained in $2? Well, it's 4 quarters in $1. So isn't that 8 quarters in $2? So that's 8, right? So if I used my division rule, I would, when I'm dividing by a quarter, I need to multiply by the reciprocal. Multiply by 4 over 1, right? So I've got 2 times 4 over 1, which is of course just 2 times 4, which of course is 8, right? This guy, 3 divided by a tenth. How many tenths, how many dimes are contained in $3? Write down the answer. Write down the answer first. Well, there's 10 dimes in $1, 20 dimes in $2. How many dimes in $3? It's got to be 30, right? If I'm dividing by a fraction, I need to multiply by the reciprocal. The rule is multiply by the reciprocal. So I'll get 3 times 10 over 1, or just, you know, 3 times 10 over 1 is 10. 3 times 10, which of course is 30. So I know this has to be 30, and then we apply the rule, and we see that, yes, the answer is 30 when you apply the rule. So my point is, do you believe now that this rule is true? That you multiply by the fraction on the right. Does that make sense? See, it's about understanding why and believe and really believing that now, okay? So the point is, if you have 3 divided by 10, you don't flip this guy and turn him into 1/3 and then multiply by a tenth, because if you did that, you get 1 over 30, wouldn't you? 1 times 1 is 1, 3 times 10 is 30. And 1/30th is not the same as the number 30, is it? Right? So you don't flip the fraction on the left, you definitely do flip the fraction on the right. So when we're dividing by fractions, we flip fraction on the right, and then so that's step 1, and step 2 is we multiply, or we multiply by the reciprocal of the fraction on the right. Same thing, flip the fraction on the right and then multiply. Okay, so these two examples, 4/5 divided by 2/15. I don't have a cool story for these ones. But what we're going to flip the fraction on the right, 15 over 2. Then we're going to multiply, and this is 4/5. Now we're back to where we were before, multiplying fractions. Do you think you can cross cancel common factors here? Yep. 2 into 2 goes once, 2 into 4 goes twice, 5 into 5 goes once, 5 into 15 goes 3 times, right? So we get 2 times 3, 6 over 1 times 1 is 1, which of course is just 6. Press pause and do this one. 3/7 divided by 9 over 28. Press pause and do it. Okay, now I'll do it. So we're dividing by this fraction. I'm going to flip that fraction on the right, get 28 over 9. I'm going to multiply now. So I'm going to flip the fraction on the right and multiply. So I have 3/7 multiplied by 28 over 9. I can cross cancel. 7 into 7 goes once. 7 into 28 goes 4 times. 3 into 3 goes once, 3 into 9 goes 3 times. And I get 1 times 4, 4 over 1 times 3, 3. And just for fun, although we're not doing this yet, but this is a mixed number. 3 into 4 goes once, remainder 1, so 1 1/3 is what that is. You probably know that already. Anyway. Okay. Page 2 now. 25/18 divided by 10. We've got to flip the fraction on the right and multiply. Although we don't have a fraction on the right, turn that whole number into a fraction. Turn all your numbers into a fraction to begin with, right? So that's going to be 10 over 1, right? So instead of dividing, I'm going to multiply by this guy flipped upside down. The reciprocal of 10 is 1 over 10. And now I've got 25 over 18 multiplied by 1 over 10. And now I can multiply the fractions. Okay. So, does anything cross cancel? 5 into 10 goes twice. 5 into 25 goes 5 times. So we get 5 times 1, which is 5 over 18 times 2. 36. And that's the answer. Okay. This doesn't simplify any further, does it? Nothing else cross cancels up here, right? Yeah, so that's lowest terms, right? Now, what if you had a number on the left? 12 divided by 3 over 4, then what? Well, same procedure. You still have to multiply by the reciprocal of the fraction on the right. You still have to flip this guy and multiply, right? And we're multiplying by 12. Although we like to turn all the whole numbers into fractions, don't we? Because then we can just multiply by fractions. So write 12 as a fraction. 12 can be written 12 over 1. And now cross cancel common factors. 3 into 3 goes once. 3 into 12 goes 4 times. So we get 4 times 4, 16, over 1 times 1, 1. And of course 16 over 1 becomes 16. Right? Good job.